NumPy side.
Yes,
So
yes.
just playing with the data to try understand how it works and how.
Yes.
You know, I understood that NumPy works on is it list?
Mostly on matrix. It was mostly on matrices. It really
On
works
Mac?
on data storage, on different data storage data types, like the lists, like the tuples, like
Yes, yes,
the matrices, yeah, vectors,
yes,
yeah.
yes. So I was trying now to what to try to practice with it. The
Yes,
division type, the division, how the multiplication of it. So I was
yes,
trying
yes.
additions of the arrays.
Yeah, like linear algebra. It's just like performing linear algebra with the NumPy, because NumPy is
Yes,
mostly
yes,
used for data, yeah, manipulation, especially matrices. Yeah.
yes, yes. So I understood that in an array, it subtracts according to the indexes.
Yes, yes.
So that is how I did it. The multiplication also, I did the division. I was trying to
Yeah.
do the indexing, the sequence of integers
Yes.
with the steps. I understood this was the step. This was the step. This was the last number, and this was the first number. The highest, then
Mm.
the steps that you need. So I was trying to do that, and now I'm still learning as I go on.
Yeah, yeah. That is really nice. That is really nice.
Mm, mm.
As you know, the concept that we give you is for you to start analyzing data. But now when you get more time with yourself, you go behind the background of these packages. You go to the background of even if cPandas has also a lot when it comes to manipulation of data. So there is a lot that you can do. We just looked at log, ilog, ads, iAds, and some of those things that relates to data. But there's a lot that you can be able to do to fetch, to actually filter and sort data. So yeah, they help us in fetching columns, fetching rows, and all those stuff. We really require them. So based on the content that we deliver, we ensure that you learn the key sector that the key things that you need to get started. And that the information will give you straightforward to you getting started with analysis of data by showing you how you can import data, and after importing data, how can you be able to manipulate data to access the columns that you want in data and drop other things that you don't want, and then conduct some exploratory data analysis to just understand the structure of your data. And then from there, we now dive deeper into the analysis side, because visualization it's just the impressive part where you can be able to easily draw insights from data, but still there is further analysis that is usually required, which is the advanced data analysis. Things like now the regression analysis, things like the hypothesis testing, one sample t-test, two sample t-test, paired and unpaired, you see. And then there is another thing now that we are going to cover today about one-way ANOVA. That's an analysis of variance. So we are going to cover that today. And that is the other part that to deal with the time series data. So we'll be looking at that in the coming sessions. And then we will look at the introduction to machine learning, where you can be able to deal with the data that is having a categorical variable that is dependent. And now you can be able to use some basics of machine learning for you to be able to draw insights from your data and like build a model that can be used to predict the likely outcomes of given scenarios. So that's what machine learning is. So our curriculum ensures that when you are given data, you can be able to transform it, give all the insights that are required, and do in-depth data analysis. but you have to ensure that you understand the basics of Python, like the in-depth usage of different packages that relates to data, like the pandas, we go in depth NumPy, go in depth, and then now you can also have look at the other packages for visualization. We have Matplotlib, we have Seaborn, and then we have Plotly. So it depends with how do you want to view your data. If you just want to see basic plots, you just use Matplotlib. But if you want in-depth plots beyond Matplotlib, you can use Seaborn. And if you want interactive kind of plots, you can use Matplotlib. You can use Plotly. Yeah, so those are some of the things that we've just covered in the previous sessions, and we are looking forward that by next week, which is the final week for the session, we should be able to have been in the position of analyzing any kind of data that we have given. So you need to be very confident so far where we have come from and where we are heading to, so that of course you'll have access to all the videos that we've been. Yes. Of course, you will be having access to all the videos that we've been using to learn, and access to the material that we'll be uploading in the learning management system. And of course, it will help you even in your future analysis. So up to there, I think that is just my input on our progress. And I would like us to proceed. So I don't know, how did you find the previous session?
It was fine. The formulas are a bit complicated, but I'm still trying to hack them.
Yes.
The only thing that the interpretation part of it, I got it.
Yes.
But now deriving the formulas is
okay, yeah. The one sample, the paired and unpaired. That's the hypothesis testing part.
yes. There was also the statistics part of it.
Yeah, the statistics part of it, yeah, it's nice. I found research on it because there is background mathematics that we usually conduct. But now when you bring it in this session, it will make things more complicated than they are supposed to be. So that's why we just, because we already have the tool like Python, so we don't have to go into a lot of mathematics theoretical calculation. But it is really nice if you can get time to look at the theoretical part as well, so that you can really understand what is happening behind. Yeah.
Yes. So I was wondering, just that we were from the previous class.
Yes.
When we were learning about the T statistics.
Yes.
And is it F statistics also?
Yes. F statistics, we will cover it more in depth today.
Oh, okay.
Yes.
It's fine then. So the F statistics is what I wanted to ask about, and also to find if there is any other kind of statistic that I need to research on.
Yeah. So today we are going to, because I did not recommend, even you see in the regression analysis, when you produce your results, there is usually that part of ANOVA table in the regression analysis, which produces the F statistics. So I did not really want to talk about it before we cover the ANOVA itself, because you could have maybe found it challenging drawing insights from it when you really don't have the background of the ANOVA. So today we are going to look at the ANOVA one way, and then we will have an assignment on the two way, of which we will discuss it in the next session as well.
Okay.
Yeah, but we will discuss the one way ANOVA, so we will know what one way ANOVA is and even what ANOVA is in general. And then from there we will have a way out. We will understand the F statistics because it's the one that is usually used in interpreting ANOVA.
Okay, that's fine.
Yes. So maybe I can start now sharing my screen.
Okay.
Okay. So if you can see my screen,
Yes, I can. Yes.
yeah. So we are looking at the analysis of variance, which we call ANOVA. And I just have some basic fundamentals of ANOVA in terms of notes here. The first thing we start looking at what ANOVA does. ANOVA, especially it just stands for analysis of variance, but is used to compare means across multiple groups to determine if there are any statistical significant differences among them. So for me, I usually like explaining these things using real world examples, so that is even easier for one to understand than even talking about it itself. So, for example, um, we have blood pressure. You know, when doing data analysis, you have to look at different sectors. So, for me today, I want to look at an example of blood pressure. So, for example, we want to know we have maybe diabetic patients, and we have two types of drugs. So, we have drug A and we have drug B. And we want to check if drug A and drug B have different influence on the blood pressure of patients, of the blood pressure of the patients. Or let me give another example. So maybe we want to look at if blood pressure or diabetes it has some an influence based on gender. Maybe, for example, can we say that male are likely to suffer from blood pressure than female? You see, so something like that. It's just a kind of a one page, like it's a kind of t-test, but it's an advanced t-test because you can be able to compare more than two groups more than two groups, if I can say, because more than two samples. Let me talk about samples. More than two samples, because in t-test we only have two samples to compare. But in analysis of variance, we can be able to compare more than two samples. So it is an advanced t-test in a way.
Okay.
Yeah, so it gives us an opportunity to be able to deal with more than two samples and again compare more than two groups. So, for example, you can test drug type of drug and also gender to the blood pressure at the same time. That is the power of analysis of variance. That is what we call two-way. So one way is where we just have one group. For example, we are just checking if gender has an influence, has an impact here, an influence, an effect on the blood pressure. Or if we want to check the drug type, if it has an influence on the blood pressure. But when we combine the two independent variable, which is gender and blood pressure, together to do an analysis, we call that two-way ANOVA because it has more than one categorical variable which is independent. So that's what actually ANOVA does, and it does not only help in healthcare, it also helps in agriculture as well. Especially, it is more impactful in agriculture. When you get time, also more you can when you do more. If you are interested more in the agricultural sector, you can learn about experimental designs or designs of experiments, where we can be able to test some influence of soil fertility on different plants, things like that, and also the soil texture. We can be able to check if it has influence on the plant growth and stuff like that. So data analysis is usually in depth, and we can be able to apply it in any field. So based on that understanding, now that's why we continue to the types of ANOVA. So one way ANOVA tests the means of three or more independent groups based on one independent variable. So In one way, ANOVA, it is not even 3 or it's even supposed to be 2 or more, because once you can compare 2, you can compare 3, you can compare 4, you can compare 5. Unlike t-test, where you just have a maximum of 2. So ANOVA is an advanced test. And then we have two-way, where you can just you can just mix between on independent variables. Okay, let me check here. I think there's something here that is kind of based on one independent variable, compare. Let me just remove this one way ANOVA test the means of one independent variable. Test the mean of one independent variable, means of one independent variable against a dependent variable, one dependent variable. Of course, the dependent variable must be one dependent variable. So what we are saying here for one way ANOVA, for example, the example we had, we are just taking as gender. Gender is an independent variable. We are taking the impact of gender on what? On blood pressure. So though gender has different groups into it, so it has two groups, maybe male and female. So there is where now you see the story of groups coming in, maybe male and female. So your independent variable must be categorical. So your independent variable must be categorical for you to be able to test one way ANOVA. So the dependent variable, yeah, of course, it is continuous. If it happens to be categorical, you make use of chi-square. Did we learn about chi-square?
No, we haven't yet.
Oh, we haven't. Okay. So I think I will be able to combine that in the next class, so that we can learn how to use the chi-square tests. So when we have dependent variable, for example, we want to know, maybe we have smoking. Okay, we have the smoking habit, and it is effect on cancer. So maybe we want to check those who smoke, do they really, what's the prevalence in health biostatistics? We relate it to the prevalence, the risk factor for cancer, for example, is smoke. Now we want to check if there is actually that influence of smoke on the effect of maybe lung cancer, something like that. And now we look at that into the perspective of, yes, you have cancer. Yes, no, we don't have cancer. So maybe we are collecting data of our patients. As patients come to our hospital, we get this data. We ask them, do you smoke? They say yes. Do you smoke? No. Have cancer. Do you smoke? Yes. I have cancer. Do you smoke? No, no cancer. Do you smoke? Yes. No cancer. Things like that. So it's like we are creating a contingency table. Can you relate on something on contingency table? Something on contingency table. Why you mentioned?
No.
Okay, yeah, you know, I teach a lot of things, so I mentioned to forget. Let me just add some more. Yeah, so let me just discuss here, because sometimes I teach a lot of things, so I may think that we already know about it, but of course we have the curriculum that guides us to know. So for chi-square test, so this one is usually used to test associations between two categorical variables. For example, when we are checking at the case that we have just had, for example, we are doing a research in healthcare, and we want to understand the impact of smoking on cancer. And now, smoking has two categories. smoking has two categories. I think I can use Excel to show this better. To show this better, let me just search here Excel and then I'll tabulate that we are explaining because it's easier to understand in when we see what we are done. So let me just open here Excel and black sheet. And so what I'm saying is, for example, we have here smoking. So smoking has, so let me combine this. I want to merge this. I merge this. And then I have here yes, no. Yes, no. So you smoke? Yes, no. And then we can have here, so cancer, we can have here cancer, yes, no. You have cancer? Yes, no. So we combine this together, this cell and this cell, we merge them. And then we say cancer. Yeah. So we want to check the association between smoking habit and the ability of having cancer. So maybe you have here people who say that they smoke and actually they have cancer. We have people here who say they don't smoke, but yet still they have cancer. So it's like a confusion matrix that we develop here. And then do you smoke? Yes, no cancer. And then here smoking and no cancer, no smoking. Maybe you say it's something like, let me use another number. How am I put it? So something like this. So when we want to check, you see now all these variables are categorical. If we have two categorical variables, we use chi-square test of independence. So you want to check if there is association between smoking and having cancer. For example, we want to really to determine, to make a decision that actually smoking is leading to high cases of cancer. So I don't know if you can get that now, Godfrey. So for chi-square, we use for categorical variables, both categorical. This is the dependent variable, this is the independent variable. So they both, when they are both categorical, we use chi-square test. But when this is continuous, we use analysis of variance, which we are learning today here. I don't know if I have explained well, Godfrey.
Yes. Yeah.
Okay, thank you. So we are learning about analysis of variance. Ivy. We are learning about analysis of variance today, and we have just said that is used to compare means across multiple groups to determine if there are any statistically significant difference among them. So like the case we have in this case, maybe we are testing, we are going to see an example down there and we'll be able to understand more about it. So today we are going to learn about one way, and then an assignment will be on two-way analysis of variance. But of course, we will discuss it in the next session, how it works, so that we understand. So for the two-way analysis of variance is where we have two independent variables. We have two independent variables. That is two-way analysis of variance and their interactions. Now we are checking at their independence. For example, we want to check gender and the drug, and also we want to check gender, blood pressure, and we also want to check drug and blood pressure. So interaction is what we call gender and drug. If there is interaction between the independent variables, in this case, for example, the example here. And then we have anyways ANOVA. This is an extension of the two-way ANOVA for more than two independent variables. Repeated measures ANOVA is used for data where the same subjects are used for each treatment. This is advanced. From here, anyway, ANOVA, repeated measures, these one are advanced techniques of analysis of variance. And then we have some assumptions of analysis of variance. So the first assumption is that observations are independent of each other. Of course, that means that the availability of one sample in another does not alter the availability of another sample when you are doing sampling, something like that. So the observations for each should be independent. So normality within groups are approximately normally distributed. Those are some of the assumptions that are statistically related. And then also the constant variance. So the purpose of our today's session is to look at the one-way ANOVA. So we want to use analysis of variance to determine whether or not there is statistically significant difference between the means of three or more independent groups. Okay, for our case, we just look at one-way ANOVA. So this type of test is called a one-way ANOVA because we are analyzing how one predictor. Yes, this is the line that you can easily understand one-way ANOVA. So this type of test is called a one-way ANOVA because we are analyzing how one predictor variable impacts a response variable. So that means there are only two variables in the equation, but one is the predictor, which is usually categorical, and then one is response variable, which is usually continuous. So we have some hypotheses as well. So that's why we are also learning about test of hypothesis. So some of the hypotheses here is that the null hypothesis is that all the group means are equal. For example, when we are using the example of gender to blood pressure. So the analysis, the null hypothesis, the claim is usually that there is no difference. All groups are equal in the same as there is no difference in terms of gender, the blood pressure based on gender. And then the alternative is that at least one group mean is different. At least one group mean is different. So maybe male is greater than female, female is greater than male. That's the alternative. So acting one way ANOVA comparison tests. Now we want to perform one way ANOVA in Python, and you need to have the data set so that we can move together. So maybe you give me a minute. I stop sharing. I upload the data set in the MLS. Today I have not uploaded the data set in a link. So let me just update the data set in the LMS so that we can get it and proceed with analysis of variance. Yeah. Yes, George, welcome. So I'm just sharing the data set for today.
Thank you.
Yeah, we missed you a lot. Where have you been?
I got late. I was to pass by somewhere.
Yes.
Then I thought I'll be home early.
Yes.
Only to find traffic on Thika Road.
Oh, sorry.
Yeah, that's why I'm late.
Yeah, sorry about that. So I'm just uploading the dataset analysis of variance. Let me just create another material in the learning management system. So I want to update the dataset that we are using today. Today we don't have a link for dataset. I did not create the link. So let me create a topic here ANOVA. So we'll be including there the materials. So this is dataset. Upload. Yeah, so today we are covering about analysis of variance, and we have just started by looking at different case studies before we go to our objective today. We have looked at a case study where you may want to check if there is effect or influence of gender on a particular disease. We have looked at the healthcare field, and so we look at the blood pressure. You see, blood pressure is a continuous variable. So we look at the blood pressure and maybe we want to check that scenario. So for our example today, we are looking at agriculture. The example we want to have here in the Python, we are looking at agriculture. So you can just check your learning management system. You should be able to see or check just your email. You will see an update that material has been created, and you can be able to get that data set there. And let's have the data set as let's have the data set. Once you have the data set, let me know so that we can be able to proceed. So analysis of variance, we use it even in agriculture. We use it even in the finance field. Sometimes we may want to know, for example, you are doing some kind of analysis to check even the employee performance on the influence of salary on influence of actually the employee performance on the salary. If the salary, the employee performance, maybe if you have a scale for employee performance, maybe 1 to 5, and we want to determine if it has an influence on the salary. So we want to see if there is a relationship between salary and the performance of the employees. So we can make use of the one-way ANOVA to be able to do such analysis. And even we can even compare different procedures of production. If they have an impact on the overall, maybe quality or overall, maybe number of products have been produced in particular hours. We can be able to apply a lot data analysis in any field. So it really depends with the passion and how you can drive insights. So can someone confirm if you've received the data, you've already downloaded it? Just confirm if you've received the data. Once you download the data, just let me know. Hello, Godfrey, so far?
I don't know why I can't download it as Excel.
Okay, how is it? How is it coming to your end?
Let me share. So,
Okay, yeah, just share.
you can see my screen.
Yeah, I can see. Click on it.
Mhm.
Then you should. Okay, there's no option for you to download it.
There is no option.
Can you click on the? Can you click on the 3 more options?
Yeah.
No download there. On open with.
Okay.
That one is Google Sheet. But you can just open it with Google Sheet and then you'll download it from Google Sheet.
Exactly.
So once it opens, you go to files and then you check downloads and then you go to Excel.
Okay, have it now. Then
Okay. You go to files and then downloads and then you choose under downloads, you choose Microsoft Excel. Okay. So let me share my screen again. Hope we have Irene. Irene, do you have?
Yes.
Okay. So we want to start by loading the data. So for my case, I already uploaded my file in a folder that is running my Python codes. So for for you, you can just go and copy the path and paste here the path. Paste here the path and change the slashes. Change your slashes direction. So once you load the data, so the normal way of loading data, for example, mine, I want to call it df, but you can call it anything, is equal to pd, this is pandas. So from pandas, we are calling a method, read underscore excel, to read an Excel file. If it is not Excel, if it is CSV, you just change here to CSV, and then you put into quotes the path to your data. So of course, you have to import pandas. So let me just have this in the chat section in case you want to use the same. So you import pandas, and then after importing pandas, you load the data, and then you print some few observations of your data. So this data is about different techniques. Different students used different techniques. So we have 3 techniques in our data. We have 3 techniques in our data, and would like to know how do the scores differ in terms of the techniques that the student used. So different students used different techniques out of the 3 techniques, and they had different scores. So we wanted to check if actually different technique for studies, that's what we refer to, the technique for studying. So we want to find out actually if there is difference in terms of the scores for the studies. So let me refer to the DF, and I just want to check technique. Dot value counts. DF dot technique, DF not defined. I have to run my pandas afresh. Yeah, so once I run that, I'll be patient. There you go. And then I go there. DF dot value count technique. I don't know. Let's check what are they saying. Technique here. Can someone just check that if everything is okay from your end? My Jupyter has been misbehaving since morning, so someone can just check if you can be able to load your data from your end.
Yes,
Someone,
on the head function took, so it's showing data.
showed what?
It's showing some data. The dot head function.
Yes.
Yeah.
It showed your data. Yeah.
Yes.
Value counts. My pandas has had a lot of problems, but now maybe technique I spelled wrongly. Let me just check. Just wanted to find out the number of techniques do I have, and I should put it into the quotes. So I just wanted to check. Maybe I spelled it wrongly, and yeah. So I wanted to check different techniques I have. So I'm subsetting, accessing my data, column known as technique, and then I value counts. I'm using value counts to access how many techniques do I have and how many values for each technique. So I come to realize that I had 10 students for each technique. And now I want to compare their scores, their performance scores, if it differs in terms of the different techniques that have been used for them to prepare for the exams. So I don't know if you have also been able to populate that on your end, just to check the value counts, the basic exploratory data analysis. Is it okay?
Yes.
Okay. Then once we have that, now we can now perform the analysis of variance. One way So we are going to use scipy.stats.f one-way function. So this f one-way function is found in the scipy.stats, but you can still use stats model instead of the scipy if you want. But for us here, we want to use the scipy stats.f one-way function to perform the one-way analysis of variance. So let me share this so that when I explain, we also maybe have the same results on our ends, so that it can be easier for us to look even at our codes on our machine. So we started by importing, have shared in the chat section. So we started by importing the scipy dot stats as stats, and then we group the data by technique. Of course, we have to group the data by technique for us to be able to compare the techniques. So we start by forming the groups. So we group the data using groups. Groups is a variable is equal to df. We reference to the data that we have. We are calling a method called group by, and then we specify which column are we going to use to group, and then we are attaching it to which column, and then we call apply. It comes out as a list. So maybe before even we proceed with this, maybe I can just print the list. The list that have been created, groups. Sorry, have to run this first before I can call that. So let me call it here. So you see now we have different lists. We have grouped our data here on top, and then we have now here 3 different groups. So group 1, we have created its list. Group 2, its list. Group 3, its list. And now we want to compare the means of these 3 groups if they are different. So that one will tell us if actually different techniques, if there is actually one different technique that it differs from others. If there is any technique that differs from others, that's what we are testing. And if there will be no, then if there will be none, then we will fail to reject the null hypothesis. So we are here. So here, we have explained this. Now we come to perform the analysis of variance. Of course, the same way we did for the hypothesis testing. So we have here F value. This is the F statistic. And then we have the P value. And then we are calling stats, a method called F one way. And then we are referring to the groups that we have created. We are referring to the groups that we have created. And then from there, for my case, I am reducing the degrees of freedom, not the degrees of freedom, but to round my values to 2 decimal places. But you can still skip this. I just rounded my value to 2 decimal places for the p value. But you can still remove this, and everything will still be okay. But you'll have everything more than, you see, your p-value is 0.0198. So if you just want to reduce it to a small significant figure, you can be able to do that using that. And then from there, now we print the f value and we print the p values. So when we look at the f statistic value here and the p value here that we have, so we usually use the p value to make interpretation. We compare it with 0.05. Either we fail to reject the null hypothesis, or we reject the null hypothesis. So when the p-value that we get here is less than 0.05, we said we do what, Godfrey? What did we say?
If the value is greater than 0.05, we reject the null hypothesis. So it will mean the population is
the p-value in this case, we usually compare the p-value. If p-value is less than 0.05, we reject the null hypothesis. But if the p-value is greater than 0.05, we fail to reject the null hypothesis. Godfrey.
okay. I got that. I think I
Yeah. Okay, yeah, you can still confuse, yeah, but that's how we look at it. So in this case, what is the null hypothesis? We can go to the top. Our null hypothesis was that all groups means are equal. You see? So, but when we look at our p-value is 0.02, that means that we reject the null hypothesis. When we reject the null hypothesis, we take the alternative. The alternative is at least one group mean is different. Now, we don't know which group is this that is different from others. So let's first of all interpret, and then from there we will see how we can be able to know which group is actually different from other groups. Which group is it that is different from other groups? So for interpretation, the F value indicates the ratio of the variance between the groups to the variance within the groups. When you look at the ANOVA table, analysis of variance table, when you can be able to compute it, you can be able to see the within groups and the between groups. So the F value is usually the division of between groups and within groups. We shall look at it later. And then a higher F value indicates a greater likelihood that the group means are significantly different. Of course, we don't have a specific value that we can call higher, but we usually have an F table. When you go to the theoretical part, we have an F table that we usually compare with this value, with this F value. But now we are usually provided with the P value that we can use with the standard 0.05 to compare, which is the next one. So if the P value is less than 0.05, we reject the null hypothesis and conclude that there are significant difference between the group means. So that means that there is significant difference between the three techniques that we have. Now we want to know which technique worked. Which technique worked? Which technique is that it's different from others? Or maybe it did not work because maybe two techniques worked and one did not work. So we do something we call, we perform something we call post hoc tests. Post hoc tests. So this one helps us to do a multiple comparison to try to find out which particular group was different from others. So this is the interesting part of the advanced data analysis. So we go again further to go in depth to find out which group was actually different from others. Now we are using the Turkish HSD test, but we have a lot of other tests that you can be able to use. But we usually at the lower level, we usually recommend the usage of the Turkish HSD test. But there are a lot of other options that you can be able to use to test. So when you meet another test that does the same work, don't get even worried. It's just the same thing. Then now we start by importing stats model. This is the stats model library that we're going to use. So import it .apr as SM. And then from the stats model.stats multicomp for multiple comparison. We are calling this method from it. So we import pairwise Turkey HSD. We import pairwise Turkey HSD. So let me just have this in the chat section. So we are really going in depth into data. So when you are given data, you can be able to know which test is appropriate for you to conduct to get more insights out of your data. So we are performing Turkey pairwise HSD. So we just take a variable, we assign it a variable Turkey, and then we call the pairwise Turkey HSD function. And then we specify the endogenous, the endog, and from here we are assigning it a particular column, our column in our data. Our column in our data here is what we call the score. And then the groups are equal to, so groups here is these are parameters. Endog and groups are parameters of the Turkey pairwise HSD. And now we are assigning these groups as the DF, the technique. So we are assigning that column, and then we refer to what alpha. So alpha is what we usually reference to. Alpha is what we usually reference to, the p-value. So if it's less than alpha, so alpha is the 0.05. And then now we print the Turkey HSD summary, the summary of the Turkey HSD to display the results. And then from the results that we get is now what we can be able to compare and actually know which group is actually different from others. We shall look at the ETC interpretation here, but I want to still give insights how this table looks like. So I don't know if we have produced the same table at our end. If you can check, just check your table. If you are all there, we can be able to interpret it before we look at on how we can be able to interpret as well. If you are there, let me know. If you are there, let me know.
You have the results.
Okay, thank you. Okay, thank you. So here, multiple comparison of means. Now we are comparing the different means, the means for different group 1, group 2, group 3. So we see the mean differences. So between group 1 and group 2, technique 1 and technique 2, the difference is 7.7. Between group 1 and group 3, which is just technique 1 and technique 3, we are talking about the mean group, mean difference. So the difference for the mean is 1.3. And then 2 and 3, technique 2 and technique 3, the mean difference is negative 6.4. Now, we want to check which group is actually different from others. Using our own eyes, we may suspect this 7.7 and negative 6.4, that they are different. They are very far different from 1.3. But let's see, what is the statistical side of it? What is the statistical side of it? So when we look at the next column is the adjusted p-values. So these are the p-values. So the p-values here, 0.0236 is actually less than 0.05. So we are looking at, again, the null hypothesis for this. The null hypothesis here tells us if the p-value is less than 0.05, we reject the null hypothesis. The null hypothesis is that the null hypothesis is that this group is equal, these two groups are equal. But now here you are rejecting it. That means that it's different. We can even check here, the last column is telling us reject, true, false, false. It is telling us which column to be rejected, which rows to be rejected, and which rows not to be rejected. So you can even look, it is also drawing it is insights from it is p-value here. You see all the other multi-comparison groups, their p-values are above 0.05. And only this one is the one that is below 0.05. So these ones we fail to reject, while this one we reject because its p-value is less than 0.05. We reject. So when we reject, that means that group 1 and group 2, they're actually different. But now we look at group 1 and group 3, they're not different. Group 2 and group 3, they're not different. But group 1 and group 2, there's a totally significant difference between the two groups. So let's see how the interpretation looks like. Let's see how the interpretation here looks like from the results there. So we start by getting the group comparison. Each pair of group comparison is listed, as we can see here. Mean difference between each pairs, which is this, and then the p-adjusted for each comparison. So if this is less than 0.05, the difference between the group is statistically significant. The difference between the two groups is statistically significant. Confidence interval, those are the lower and the upper. The lower and the upper bound. These are the bounds of the mean differences. The bounds for the mean differences. And then reject, so indicates whether the null hypothesis, that's the mean are equal, is rejected for each pair of the groups. So yeah, so that's how we interpret this. And so from here we can see which groups are different from others. So we can see that we can even visualize that, which is step 5, to see how this means tends to be. But from here we can know which group is different from another. So we are, while formulating the hypothesis, we usually have something like this H1, which means that the mean mu1, not H1, mu1, mu the mu symbol anyway, mu1 is equal to mu2, like the mean of group 1 is equal to the mean of group 2 is equal to the mean of group 3. Mean of group 3. So this is the hypothesis. So when you are rejecting this, that means that at least one group is different from other. So they can be two that are different from other depending on the number of groups that you have. So for us, we have went forward and did some tests to check. Actually, we said there's some groups that are different from each other. Which groups are different from each other? Now we go ahead and look at this. We go ahead and look at this to check actually what's happening. And then now we realize that group 1 and group 2 are not equal. So these ones are not equal. As much as group 2 and group 3 can be assumed to be equal, then that means that the mean for group 1 is actually totally different from the mean of group 2. It's far away. It's far away, which is this. That's the technique. Mean for the technique of group 1 is actually different from others. So we can be able to check that. Can be able to check that. Let's check their summaries using let's check the summaries, the describe for us to see. Let me just create here a new cell for us to see which let's just check their summaries. Of course, group. Okay, groups are already listed. They're already listed. Cannot be able to perform on the list their means. So yeah, cannot be able to check that. But we will have to create another groups for us to be able to compare their individual means. But we just have their mean differences. Yeah, so let's visualize it. Let's visualize this to see how they are far from each other. If we don't want to see their means, but let's first of all visualize this to see how they are far from each other, because their means, of course, they will be populated here. So we start by importing matplotlib for us to visualize this data, and Seaborn as well, for us to visualize the means for these different techniques that we have here in these cases. So from there, let me just take this. We just want to build some box plots to check which means are different from others. And we start by calling a box plot from the Seaborn, and then we specify x-axis. What do we want? We want techniques. Y-axis is the scores. From which dataset known as DF. We give the title, score by technique. We show the plot. And then from there, we can plot the results of the Turkey HSD also, and stuff like that. So let's check here. So here, we're trying to check their means. So technique 1, its mean based on its rank, it has values at around some lowest values around between 70 and 75. You can look at that data, and some values, it has the maximum and the minimum values. And then group 2, technique 2, has values ranging between 85 and 95 in between that range. Yes, and this third technique, these are the scores. So technique 2, its scores is there. Technique 1, its scores is there. And then technique 3, its scores ranges between this and this. So if you can remember about box plot, maybe what did we say about the 5-number summary on the box plot? Can someone remind us about that? Can someone remind us about the 5-number summary on the box plot? I don't know if you have the same results. Maybe George, do you have the same results? And you can be able to, it's just that plot and this plot, which is just
Yes, I
so
have.
yes, yeah. This plot above is, this one is about the multiple comparison between groups, their mean where their means are located. This is where their means are located, like the visual of this. So maybe if you can share your screen and tell us about the box plot. If you can remember about the exploratory data analysis box plot, what does the whisker stand for? What does this 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 stand for the box plot? Yeah, so maybe your colleagues can also help you somewhere so that we can be able to learn, to remind ourselves.
I think we need to remind all of us.
Yeah, what does box plot say?
Let me just try. Let me share the screen. Then we'll try to remind each other.
Yes.
Yes. So here you can see my screen, eh?
Yes. We can see your screen.
Okay. Now, if you take the first box, I think the line striking the box is where we have the mean, and then down here is we have the first, was it quantile? Then we have upper quantile. We don't have any outliers indicated.
Yes.
So yes.
Yeah, just remind us again. You've said.
So what I can remember, where
Yes.
the line is striking the box,
Yes.
I think that's where the mean is.
That's where the mean is.
Then from the lower whisker,
Mm.
we have the first 25% of our data. Then we have the 75% at the
Why is
middle.
the 75?
And then we have
Why is the 75%?
the 7. I can't quite remember where exactly it starts and ends.
Yeah.
What I know is we have a first quartile, second quartile, and third quartile.
Irene, just there, George, just stop there. Your screen. Don't stop. Don't stop sharing. Maybe Irene can also remind us what we learned about the exploratory data analysis on the. Don't stop sharing. Yeah, Irene.
Okay, so where we have this whisker upper between 70 and 75 is the minimum value, if I remember very well. And then upper kwa hii box between this line, between 70 and 80, I think that's the first quantile or the 25th percentile, and then this line that cuts across is the median. And then this other line between 80 and 90, I think is the third quantile, and then this upper one is the maximum value.
Okay, thank you. Hey, sorry about that. George, umesikia hiyo? George, have you heard that? Can she repeat?
You can repeat, or you can repeat, or you can extrapolate on our behalf.
Yeah, so 5-number summary. Box plot is usually a 5-number summary. So The lower whisker, the lower line on the whisker is the minimum value, and the lower line on the box is the first quantile, Q1, which we usually refer to as the 50th percentile of our data lies there. The 25th percentile of our data lies there. And then the middle one is the 50th percentile of our data lies there, which is the median. And how do we get median, first of all? How do we get median? We are reminding ourselves, how do we get median? Yes, George, are you talking?
No, but I think is where we have a midpoint of the data.
Midpoint of our data. So when we want to get median, we have to ensure that we sort our data. First of all, we start by sorting your data, either ascending order or descending order. And then from there now, you check the middle point of your data, as just the way George has said, the middle point. So if it is odd, if it is odd, you will get one value. If your data is odd, you will get one value. If your data is even, you will get two values. So you have to again divide the two values for you to get the middle point of your data. So what is an odd data? Because every time we mention some things, we tend to get more and more questions about ourselves. So what is an odd data? What's an odd data? Odd data. Odd. And what's even? What is an odd
Can I
data?
try?
Yes, yes.
I would say odd data is a data set that is not divisible by 2, and even data has a number of data that is divisible by 2.
Yes, yeah, that is right. So when your data is odd, the median point, which is the middle point, will be a one value. But if your data is even, you will get two middle values. So you have to add them and divide them by 2. And then from there, we have now the upper quantile, which is the 75th percentile of our data. And then we have the maximum value, which is usually the upper whisker. The upper whisker. Yeah, so depending on what we see there, we see that some other values, even when you check the lists that were created as groups, that means when you check in the groups, the minimum value for group 1 will be around 70 to 75 there. So it's around 72, something like that, or 71. And the maximum value in that case is 95. So the mean for that data range will be altered, will be affected in a way due to the spread of the data, due to the dispersion of the data. So its mean is affected in a way because its data is dispersed away from the mean. And when you look at the second technique, its data ranges between 85 there to 95. So when you do actually its average, its value for average will tend to be somewhere around a 90 something. Yeah, it's mean it will be closer to the median because the more the data is not spread as much, the more the mean will be equal to the median. Yeah, because you're learning this because it's the fundamental of data exploration. So while plotting your histograms, plotting your density plots, you can be able to make understand of that. So when you come to mean being equal to median, when mean is equal to median, that means that the dispersion of data is not that much. That means that the data is normal. That means that the data is normal. The data is concentrated at one place. There's no long tail. There's no long tail to the left, and there's no long tail to the right. Things that we call skewness. And the last part is the last box plot is for the technique 3. We see that its value ranges between 79 there to up to 94, 95, something around there, 94 there. So also its mean will be kind of different. But now we can be able even to have a look further by scrolling down on the multiple comparison. Scroll down so that we can see the, okay, yeah, there. So the first case, its mean is in between 82 and 84. And the second data group, its mean is around 90 and 92. And the third data group, its mean is between 84 and 86. So that means that the more the higher the mean, the higher the difference. So when you check our mean for technique 1 is between 82, let's say is 83, and the mean for group 2 is 91, let's say that. So you see that difference will give you a very big discrepancy. It will give you a very big difference, mean difference, which will cause the rejection of the null hypothesis, because group technique 2 has higher mean compared to technique 1. And you can also compare technique 3 in the equation, that technique 3 is not that different from technique 1's performance, because here we just have 80, maybe 85, and here we have 83. It's not that different. But when you look at technique 2, it is that far away. It's 90 something. So it is totally different from technique 1. But it was also about being different from technique 3, because it has 0.06. So it's just around there. But from our own eyes, we could have said that it's different. But now, statistically, it is not different with group 3, but it's different with technique 1. So this is what we can be able to draw from the data when we want to use analysis of variance to check if there is difference in the means of different groups on a particular dependent variable. For example, in this case, our dependent variable is scores. So when we want to check the techniques, how different techniques leads to different scores, now we make use of the analysis of variance. I don't know if we have understood the analysis of variance or not. What have you understood? If you can give us an example that you understand better, how we can use analysis of variance, each one of us to give us an example. So maybe I start with Godfrey. He'll give us an example of analysis of variance one way, just like the one we have learned. In which way can we apply, like the application of analysis of variance? Yes. Godfrey, are you there with us?
Yes, can you hear me now? Yes.
Yeah, we can hear you. Maybe you were talking on mute.
Yeah. So one way how you can probably use it. Let me use an example of T. Yeah, we have different kind of T. So you can try probably to identify the satisfaction or how many people take different kinds of T, and try to find the probably the difference the variance between the usage of the tea.
Yes, 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 yes. Yeah, that's nice. So we can even do that. For example, we can do that for let's say we collect data for a period like of 1 month, and we just take the satisfaction. We capture just the people do the ratings about different types of teas that they take, some things like that. So maybe we have 3 products of teas that we have, and now we want to know which one do they prefer and which one is better, and like the preference differ. Does the preference differ? Yeah, so that's what we can use now to check if actually the preference is significant. Does it have an influence on preference? The type of tea, does it has an influence on the preference? Yeah. So that's what we can be able to do, Godfrey, and that's nice. Irene, how do you think we can be able to apply this, depending on what you do or whatever way you've understood one way or another?
Maybe to compare probably different medications, maybe like in a hospital, one is given probably a different kind of medicine from maybe probably different patients, maybe suffering from the same disease, I would say, given different medicines to check how probably each medicine is different from the other and the effects of probably the medicine from one patient to the other.
Yeah, yeah. So yeah, that's really, really, really nice, very insightful. So you come to realize that we can really apply this in different sectors. As we have just said, for example, we want to check the impact. For example, maybe there is a particular key performance indicators that was being observed to measure the level of COVID-19. Maybe if it is temperature, maybe if it is yeah, anything, let's say temperature. So maybe we give a different, remember we had different drugs, different vaccination for COVID-19. So maybe we give people different vaccinations and we want to check if actually which vaccination performs better than the other, or if there is difference in terms of performance. Of course, we are relating to the temperature. So we can be able to use the one way ANOVA to be able to conduct that. But if we bring in the aspect of gender, maybe we wanted to know if there is different action, different reaction of COVID-19 on different gender, and then that one is now on different gender, and again, we combine in with the particular type of drug. Then that one is a two-way analysis of variance when we want to bring in more than one group comparison. Yeah, so go, George.
I don't know whether this will be more than one group. I was thinking of.
You give us your example. Yeah, give us.
I was thinking of maybe when we can try to see the impact of the new curriculum, the CBC, vis-a-vis 844. The impact either on creativity between the just outgoing 844 candidates and the current JSS candidates at grade 8.
Hey, you want to to give a CS the report, the CS for education report?
Of course, yes.
What? Okay, so maybe now you repeat your scenario. So you want us to compare. Are we comparing the skill wise, or are we comparing the performance? What are we comparing?
We can just take maybe one aspect, because
Yes,
the
yes.
JSS, the CBC is being we are being told that it's going to make kids to be more creative. Maybe we can look at the aspect of creativity. We can measure creativity between the current students and the ones currently at form 1. Those are the last class which finished 844.
For me there, you see,
Yes, please.
for me there, I would go with the chi-square. I would go with
Okay.
chi-square than analysis of variance in that aspect, in that direction, because I'll require, because how will I measure creativity? You see, you need to see how will I measure it. For me to measure creativity, I have to measure it in a categorical way. And now I will be comparing it with either the mode of education, which is either CBC or the previous one. So for that one, you go back to the table that you came while I was using Excel to plot that, to plot the contingency table. So for that problem, contingency table works better than the analysis of variance. So maybe I share my screen on that so that we
Let
can
me
know
stop.
the difference between
Let me
ANOVA.
stop sharing.
Okay. So that now we can know the difference between analysis of variance and the chi-square. We say that when we have categorical variables, for example, in this case, maybe we were associating smoking and cancer, lung cancer, that is. So when we compare that in that direction, we use the chi-square test. But remember, your scenario is mode of education, so we can just combine this mode of education here, mode of education, and now we can have here we can have, so let me say here is the creativity. So creativity level, let's say we have low, we have medium, and then we have high, medium, and we have high level of creativity. And now we have creativity variable here. You see now it is easier for you to measure creativity categorical variable because it's emotion. Creativity comes to, is like emotional thing. So you have to see how you will measure it before you choose the appropriate statistical test. Then the mode of education here, I have to insert here another row. Or I just copy this, cut this, and then paste here. Yeah. And then here I can have CBC, and maybe 844. 844. Yeah. So you see, so I will need to know how many students for CBC have low creativity, how many students of CBC have medium, how many students of CBC have high, how many students of 844 have low creativity, how many students of 844 have medium, and how many students of 844 have high. And now I want to test if there is association between the mode of education and the level of creativity. Remember, there might be no relationship. Maybe creativity is just on its own. It doesn't depend on which mode of education you took. So we just test the association to check if there is association. And if there is association, then now we can proceed and now be able to check how these groups differ, these values actually different. So maybe if we have something like their means, is where now we can proceed and now compare their means now. So I don't know if you get me up to that point, George.
Yeah, I get it. I get you.
Yeah. So there is a lot that we can do with the analysis of variance. So today we have looked at the one-way ANOVA, but I have an assignment for two-way ANOVA that I'll be able to give you, and I'll give you the data set as well, so that you can explore on one way. You can use it. You can use one of X variable to test one way as well, and then from there you can learn about two-way. But I will still explain the two-way in the next session. In the next session, I will also consider the chi-square. I will consider the chi-square as well, so that we also understand chi-square is very, very helpful when it comes to categorical points. So I will also consider chi-square, and from there, we will learn about um, introduction to. We will do a time series analysis. We will do a time series analysis. We will see how it is going to be, but that's how it is going to be, and Time series analysis and machine learning should be next week, but we shall see what we can do. We can use the next session to learn about the two-way analysis of variance and also to learn about square. Yeah, so that's what we are going to learn. So let's ensure that we practice on whatever we learn. Let's try to ask where we feel we are stuck, so that we can be able to help each other. We will as well be able to upload more materials on the learning management system to help us catch up and maneuver any kind of data that we get. Because remember, at the end, we have a final project. So we'll be sharing with you a data set for you to explore everything you can be able to explore from that data, from whatever you've learned and extra thing you see it's possible with the data that you will have.